Hello, everyone. A very good morning and good afternoon and good evening to all. Dear authors and invited guests, we welcome you to the technical session 4B. And my name is Anisha Mishra, and I am the moderator for today's session. So on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology, ICICT 2023. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th and 21st February 2023. And the virtual event will be held through Zoom today and tomorrow. Yesterday and today, that is 22nd and 23rd February 2023. So, and I hope you will all enjoy the knowledgeable and interactive sessions through the day. So in this session, we have 6 presentations and each presenter will be given 12 minutes for their presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So as we start the session, I would like to introduce you all to the chair of the session, Dr. Diana Oresky, but for some reason, she has not joined the session yet. So we are waiting for her. And we have another session chair for the session, Professor Monica Rathore. So Dr. Monica Rathore currently is associated with IIM as Associate Professor, over 15 years of MCA teaching experience, Research Supervisor at Rajasthan Technical University, Kota. Currently, 6 students are pursuing PhD in computer science under her supervision, and more than 20 research papers have been published in reputed journals. So, dear ma'am, we welcome you to the session.
Thank you so much, Anisha ma'am. Am I audible?
Yes, ma'am, you are clearly audible.
Okay. So, welcome to the technical session of 8th International Congress on Information Communication Technology. I'm Dr. Monica Rathod and I'll be co-chairing this session along with Professor Dijana Oresky. So this session will run from 9:30 a.m. till 11 a.m. and there will be 6 talks. And every speaker will have 12 minutes for their presentation, followed by the 3 minutes for question and answer. Everyone clear? 12 minutes for the presentation and followed by 3 minutes for question and answers. So first, I would like to invite Ms. Ruxi Ziang for this paper, Deep Aware Network for Removing Single Haze. Mr. Ruxi Ziang, over to you, sir.
I think he has yet not joined the session.
Okay.
So, okay, yeah. So for now, we can continue with our session and we can call our next presenter. So I would like to invite Reed Melivics to present his paper on the title, DevOps Pragmatic Practices and Potential Perils in Scientific Software Development. So if Reed is here, you can present your paper now.
This was Miranda Munt. I will be taking Reed's place. He was unable to make it today.
Okay, so you're presenting on behalf of Reed?
Yes.
Okay, that's fine. Yeah. Please go ahead.
Let me know if you can see my screen. Can you see the screen?
No, it is not visible yet. Yeah, now we can see it.
Okay, great. Hello all, and thank you for attending this presentation. As I noted, my name is Miranda Munt. I'll be filling in for Reed Malevich today, who is unable to attend. I am a research software engineer from Sandia National Laboratories located in Albuquerque, New Mexico. Today, I'll be speaking to you about our DevOps pragmatic practices and potential perils in scientific software development paper. First, I want to talk to you about the changing landscape of high-performance scientific computing. It will come as no surprise that computing has become integral to the process of scientific discovery over the past few decades. In fact, one US government-funded study estimated that every dollar invested in high-performance computing generates an average of $507 of new revenue and $47 in profit or cost savings. High-performance computing today plays a central role in discovery, economic competitiveness, and national security, both in the United States and across the world. Gone are the days where a single researcher develops scripts in isolation to answer a research problem. Rather, in today's ecosystem, it's defined by community-driven open source software. Indeed, this is reflected in the rise of roles such as research software engineers and DevOps practitioners. We're seeing more adoption and interest in modern software development tools, practices, and perspectives. There's a desire to improve productivity in these larger, more complex teams that correlates to the adoption of modern tools and practices, such as version control systems and automated testing pipelines. Today, we're going to focus on one area of this, DevOps. Now, this may lead you to ask, what is DevOps? DevOps stands for Development and Operations. This concept came into existence in 2009 and 2010, when there was a realization that the traditional model of separating initial project developers from long-term maintainers created challenges in the software development lifecycle. We use the definition listed here for DevOps, a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production, while ensuring high quality. In other words, DevOps is what allows us to frequently update our code while minimizing downtime, outages, or failure. The emphasis on DevOps here comes primarily from the goal to make a more cohesive and iterative product. But here we already see issues in the definition. Product. Within the scientific community, rarely is the software the product of the research. The product of the research is the results. But these results depend entirely on the correctness and reliability of that software. So now, more than ever, DevOps is critical to the future of computational science and engineering. The body of gray literature in particular on this topic has been growing at a rapid pace. Blog posts on websites such as Better Scientific Software detail the experiences of scientific researchers to adopt DevOps practices. Conferences and workshops have dedicated tracks geared towards DevOps infrastructure and pipeline development. The common theme for these different explorations of DevOps in the computational science and engineering domain, though, is the need for adaptation. Software must remain agile and be able to evolve quickly with changing requirements and resources. Many times, these requirements or resources are unique, cutting edge, and unexplored by industry at large. As such, there's a demand for adaptation and innovation in DevOps tools and practices. That which works for a web application or word editor is unlikely to perfectly fit the needs of a cross-domain, multi-physics, high-performance computing application. At present, the formal research into these innovations and adaptation is critically understudied. In conducting our study, we hoped to glean a deeper understanding of how DevOps work is done in computational science and engineering contexts and what needs practitioners have. This, we hope, will allow for us to inform the design of better tools and techniques, support effective policymaking around cyber infrastructure sustainment, and raise awareness of the critical role played by DevOps practitioners in advancing science and engineering. For this study, we mixed together experience stories and an overview of the existing body of literature on DevOps practices in industry. We conducted a participatory action research study. That is, we reached out to a variety of DevOps practitioners throughout Sandia National Laboratories to gather their experience reports as practitioners within computational science and engineering teams. In particular, potential contributors were asked to provide stories about their experiences conducting DevOps in scientific software development, their successes, failures, challenges, in topics such as testing, team policies and procedures, and technology stack modernizations. After collecting these stories, we analyzed them through the lens of the scholarly literature on DevOps. In particular, we focused on 2 systematic literature reviews on challenges and best practices in DevOps in industry. In all, we collected 13 experience reports as depicted in the table and detailed in full in the paper. We compared these results to studies of DevOps in industry through that targeted literature review. Those two systematic literature reviews presented a cohesive, holistic view of the current state of DevOps. Throughout this analysis, 4 main themes manifested: software development lifecycle, testing from both a technical and cultural perspective, team policies and processes, and institutional support. Next, I will highlight a few of the stories we collected that showcase these themes. First, in this experience story, the practitioner speaks specifically to technical challenges in setting up efficient testing infrastructure for large, complex, and highly modular scientific libraries. As the practitioner notes, for any given change, tests take an average of 6 hours and up to 11 unique builds. This scale of testing cannot be easily handled by free services such as GitHub Actions, thus requiring a homegrown tool and infrastructure. This challenge is exacerbated by the lack of appropriate experience and funding to maintain said homegrown tool, thus causing it to decay while the codebase constantly evolves. In the second story, we see that other challenges come in the form of resistance to change. The practitioner here tells of their team attempting to adopt a standardized and enforced code review process. Many team members criticized this change initially. It slowed down work and introduced extra overhead that generally the team members did not see as valuable or necessary. As the process became ingrained and normalized, however, the team began to see dividends on their investment. Breakages happened less frequently, code quality generally increased. What started as a time sink turned into a productivity gain as the infrequency of breakages freed up availability to better maintain and develop on core capabilities. As our final highlight, this is one that we can all recognize: the need for institutional support. In this story, the practitioner stresses the importance of leadership, decision makers, stakeholders, and funders understanding just how much time and dedication is actually required to successfully implement efficient DevOps processes. From design to maintenance, it takes commitment and buy-in. To truly get that buy-in, however, there needs to be a shared understanding throughout the entirety of the software lifecycle, from funding calls to release to maintenance. Without an understanding of that underlying complexity, there will never be a true paradigm shift. For all 13 stories, we compared their contents to those of those 2 main literature reviews, one detailing challenges and one detailing top practices for DevOps success. In this table, we see that the experience stories mirror the most common challenges in DevOps and industry. Many of the obstacles encountered and overcome by our participants are not unique to computational science and engineering software development. Successful implementation of DevOps tools and practices requires addressing quality in the systems under the tests and the tests themselves, while a lack of knowledge about DevOps can hinder overall implementation or lead to suboptimal decision-making. Where DevOps infrastructure exists, it must be actively maintained to keep it up to date and to manage complexity creep. Having the support of leadership and buy-in from development teams is critical to success, as is promoting communication and collaboration across teams and organizations. Shifting the focus, let's compare against positive practices. In this study, we can see that our stories are reflected in 10 of the 12 top-ranked DevOps practices according to Akbar et al. DevOps adoption and implementation is seen as successful within a more collaborative culture with a shared value system, which is bolstered by the education of both staff and leadership. The practices succeed only insofar as there is standardized buy-in and adherence. Constant communication is seen as necessary to minimize the potential for issues and inefficiencies. One story only touches on the rapid deployment as a way to receive constant feedback from customers, something that shows us the difference between industry and scientific software development. When it comes to automation, there's a strong emphasis on the importance of continuous integration and testing, but this cannot be applied unless a team can decide what it actually wants to achieve first. Additionally, DevOps practices are widely more successful when started on small, young projects, especially if the project monitors and adapts their practices as it matures. Overall, we see alignment across DevOps practices and perils in both industry and computational science and engineering contexts. For computational science and engineering, however, many open questions remain before DevOps can be adopted in a scalable, reproducible manner. For example, as a project does mature, at what point does the team scale up their DevOps practices? At what level of maturity is it correct to start implementing, say, automated testing pipelines? Do certain tools or practices align with stages of maturity? And if so, what are those tools and practices? And when it comes to research code, how often should it be released and deployed? And after it's deployed, what does operations and maintenance really look like? As software becomes more integral to the advancement of science, so do the processes and procedures used to create scientific software. In our study, we collected experience reports from DevOps practitioners at a US national laboratory. We analyzed the commonalities and differences between the industry and scientific software DevOps practices. DevOps in this context of scientific computing is a research realm that is rich in unanswered questions. We shared some of these, as well as lessons learned, to add to and promote further conversation. Thank you so much.
Thank you so much for sharing your knowledge regarding DevOps technologies. So I have one question, like, can you please tell me that how the DevOps different from the Agile methodology?
So DevOps actually came out of the concept of Agile methodology. As I noted, it originated in 2009 when there was a DevOps conference that kind of came about naturally by a bunch of people who'd thrown around this term. Realistically, DevOps is more of an extension or an application of Agile, whereas Agile is more of a high-level methodology.
Okay, and can you please tell me some issues related with the DevOps technologies? What are those issues?
Do you mean within industry?
I mean with the limitations of the DevOps.
So some limitations are generally speaking, depending on your team composition. So when it comes to DevOps, and one of the bigger challenges that you get, particularly in computational science and engineering, is that you need to have people who have strong ability to do every piece of the software lifecycle, or at least understand. So they need to have, good experience from design to maintenance. And frequently, especially in computational science and engineering, you don't have people who get that sort of experience because they're self-taught. They, have learned this on the fly as they've needed for their job, as opposed to being trained in how to do that specifically. So that's one of the bigger challenges that you see in these sort of DevOps development pipelines is the lack of experience in one stage or another.
Okay. Thank you so much for sharing your knowledge with us. If anyone is having any query, he or she can ask to her. Okay, so we will move on to the next paper. Anisha ma'am.
Yes, ma'am. So we'll move further to our next presenter, and I would like to invite Hiroki Kimura to present his paper on the title Funnel Control for Multi-Agent Systems in a Disconnected Condition. So, dear presenter, you may please present your paper now.
Yeah, can you hear me? Can you see my screen or presentation?
Yes, it's visible.
Okay. Thank you for your introduction. I'm Hiroki Kimura from Tokai University. Today, I'm going to talk about funnel control for multi-agent systems in disconnected conditions. As a background, the multi-agent systems has gathered attention for efficient cooperative operation of multiple robots. However, previous studies on multi-agent system have assumed an ideal situation in which the graph is always fixed or connected. So the subject of this background, the graph is not fixed if the agent is assumed to be actual robot and its communication range is considered finite. So the consensus may not be achieved. So the purpose of this research, the proposed control method based on funnel control that was applied to a multi-agent system considering disconnected conditions, and perform simulations to verify the effectiveness of the proposed algorithm. So as a preliminary step, I will talk about graph theory. As shown in this figure, the figure composed by vertices and edges is called graph. And each edges has a direction and indicated by arrows. And if the edges is bidirectional, then these marks are omitted. And here, if this graph G, which is not the edges, which has not bidirectional like these edges, this graph called directed graph. And in contrast, if all edges has the edge with bidirectional, this graph called undirected graph. And after here, the graph is regarded as undirected. In this page, I will talk about adjacency matrix A. This matrix representing the adjacency from vertex I to J, and this is the definition of the element of adjacency matrix. So if Hij exists, this element given 1. So for example, in this case, H1, 2 exists. So the element of 1, 2 given 1. Next, I will talk about degree matrix D. This matrix representing the in-degree of vertex I and given by these equations. And this graph Laplacian L is very important in multi-agent system because determining the graph characteristics. And given by this, the definition is these equations. And next is, next I will talk about consensus problem. And this page I will talk about the agent assumption. And the agent is assumed to be omnidirectional mobile robot in this study. So this is example of omnidirectional mobile robot. So the agent has no constraints on its own direction. And agents are represented as a mass model, and the state variable of agent I is given by these equations. So this X and Y is the coordinate point. And moreover, multi-agent system in this study is assumed to be discrete time system. So this K is the sampling time. And the differential equation of the dynamics of agent I is given by these equations. And this zeta is this state variable, and TS means sampling time, and the UI is input for this system. So finally, we obtained these equations. So this graph Laplacian L is determining the characteristics of the dynamics. In this page, I will talk about consensus. So consensus means a symptotic convergence of the state variables of all agents through information exchange with neighborhoods. This is one example of the consensus simulation. And this dot or circle means agents, and this line is the connection between them. And after that, all agents will converge. And finally, all agents converges maybe this point. So all agents satisfy this equation. So we confirmed consensus was achieved. And when considering application multi-agent system to actual robot, autonomous decentralized system is required. So in this case, assuming each agent communicate with each other using wireless communication devices. So therefore, each agent has exchanged various information within a finite range. So it is needed to restructure the system considering the communication range. So details are explained in next page. So this is the definition of the element and the graph, adjacency matrix A. But this, in the previous studies, this adjacency matrix is always fixed. So need to reconstruct by this communication area. So this is the communication area with agent number 1. And this agent 1 can detect agent 2, but cannot detect agent 3. So the connection is disconnected, and the element A13 becomes 0. And this is case for agent 2, and this is case for agent 3. So now conventional definition. This conventional definition is reformulated by this communication area or communication range Ri. So next, I will talk about funnel control. The funnel control is a high-gain adaptive control method proposed by Ahem Ilhiman. So this is the concept figure of funnel control. This method aims to converge the tracking deviation EI within a predefined performance funnel F5, this blue shading area. So this aim is like this. So this red is the deviation E. And this F5 performance funnel F5 is expressed by scalar function phi k and given by these equations in this paper. And this is a control method using funnel function. This funnel function and this E is control gain and given by these equations. And this gain means that if the E gain is become large, the gain become large. Sorry, this deviation become large means the gain become large. So namely in this figure, the closer the error is to the boundary, the larger the gain. However, the previous method is designed for the case where the graph is fixed. So modifications are needed for the following 3 issues. First is event-triggered network changes. The second is decreased convergence speed. And third is impact of number of networks. So therefore, we propose a newly funnel control to solve those issues. As a modification to the first issue, the time tau is established, and this time is defined these equations. And as a modification to the second issue, the decreased convergence speed, this phi is this is a boundary function of the performance funnel, and it's changed, and especially the decrease immediately after start here. The study is suppressed. As a modification to that issue, the gain is redesigned. So new design, new gain is epsilon phi, and given by this equation. And here, this d is in degree. So in this case, if agent 1 for agent 1, in this case, the y in is 3. So finally, new inputs is obtained by these equations. And after here, this method is called proposed method. Oh, sorry. So sorry, I don't know why I said. So in this section, I will explain about simulation overview. And this simulation is, the purpose of this simulation is perform validation of effectiveness of consensus control based on funnel control. And this movie or this figure shows the previous the simulation result with conventional method. So all agents restart. So like this. So if using conventional method and with this communication range, so this situation cannot achieve the consensus. And 10,000 different conditions were prepared like this situation. So all all 10,000 cases cannot be achieved consensus using conventional control method. And this is the simulation result after using proposed method like this. Consensus was achieved and confirmed that all agents converged in one places. And this is simulation result with time history response of deviation and this funnel function phi. As a number one, this phi.
I'm sorry for interruption. Kindly conclude fast.
Oh, please. So at this time. Okay. Sorry for the shortcut. So this is the control simulation result, and we confirm all cases can achieve consensus. So this is conclusion, and we confirm the consensus was achieved for all cases, all different initial conditions, and proposed method was effective for virtual system considering the limited communication range. And this is the future plan. Oh, sorry for time. Thank you for your attention.
Okay, thank you so much for your presentation. Can you please briefly explain me that what you understand by the multi-agent optimization?
Sorry, I'm not good at English, so please speak slowly, please.
Yeah, I'm trying to ask about multi-agent optimization, wherein we can make sure the participation of all the agents. Okay, what are the different challenges associated with the multi-agent system, multi-agent learning?
Learning, I don't use multi-agent learning. So
especially in terms of the computational complexity, if you can explain me. What are the challenges associated with multi-agent system?
My challenges?
Yeah, challenges. What are the limitations in terms of computational complexity? The multi-agent system, yeah.
So almost multi-agent system is considered the all agents, this connection is always fixed. But in case we consider that each agent is an actual robot, so the communication range is limited. So if the like these simulations, so our challenge is the conventional, when using conventional control method, the consensus does not achieve because this limited range. So
okay, thank you so much for your presentation. Anisha ma'am, we'll move on to the next paper now.
Yeah, okay, sure ma'am. So now I would like to invite our next presenter, Sulafa Bedi, to present her paper on the title, How can blockchain technology be used to manage the COVID-19 vaccine supply chain, a systematic literature review and future research direction. So, dear presenter, you may please present your paper now.
Thank you, Anisha. I'm just trying to share my screen. Okay, so can everyone see my screen?
Yes, we can see it.
Oh, brilliant. Yes, so pleasure joining you today. Yes, everyone. Sulafa Badi, I'm an associate professor at the British University in Dubai in the United Arab Emirates. And I'm delighted to present to you my paper on how can blockchain technology be used in the management of the COVID-19 vaccine supply chain. It's an ongoing piece of an early paper of an ongoing research project with colleagues from Zayed University and Higher College of Technology in the UAE, where we try to build a view of the current state of knowledge and about the use of blockchain technology on COVID-19 vaccine supply chain management. So I'll just start, if I can, yes, about the context. So the context of our study, of course, we all know the devastating impact of the COVID-19 pandemic. Just a little bit of background, I'm sure we all know it. It started in December 2019, spread in China, then spread throughout the world. And it was designated a pandemic in March 2020. And as I've checked a few days ago, so as of February 2023, over 6.87 million people have died from the virus, so making it one of the worst pandemics in recorded history. So vaccines, of course, were developed quickly in 2020 for our rescue, and they were successful in reducing disease severity and fatality. And again, I've checked a few days ago, and I found that there is a total of 13 billion vaccine doses that have been administered worldwide. So when we look at equity and vaccines, and I think the figure we can see there on the screen shows the total COVID-19 vaccine doses administered per 100 people, we can clearly see that there is a high inequity in vaccination across the world. So you see that access to vaccines has been uneven, with high-income countries receiving more doses than low-income countries. And there is an initiative called COVAX, which stands for the COVID-19 Vaccines Global Access, which aims to increase equity and transparency in access to vaccines throughout the world. Our focus of our study is on the supply chain, and we believe the supply chain has an immense role in ensuring that vaccines are produced and distributed quickly, safely, and efficiently to people who need it. And when I say the vaccine supply chain, we are referring to a series of activities and processes involved in the initial research and development of potential vaccines, through to the manufacture and distribution of the approved vaccines, and then to healthcare providers, and finally the administration of the vaccine to the public. So the COVID-19 vaccine supply chain involved multiple actors, including research and development organizations, drug manufacturers, distribution hubs, and healthcare facilities. So it's a complex web of interconnected activities. Of course, the COVID-19 pandemic itself and restrictions of travel, etc., have impacted the supply chain activities, but there were other issues that impacted the supply chain as well. So in our study, we identified several challenges encountered by COVID-19 vaccine supply chain management. Among those issues is supply network design. So the conventional COVID-19 supply chain is a centralized supply network design with single points of failure across the supply chain. We've also, in our research, have found that there were issues in terms of drug counterfeiting in some regions of the world. There was also some communication challenges in terms of miscommunication between stakeholders that disrupted distribution planning of the vaccine. Security challenges were again major issues in the COVID-19 supply chain, where it was prone to cyber attacks, and there were issues in terms of transparency, auditing, and traceability of the vaccine. Among the other issues we've identified are privacy challenges, including sabotaging of sensitive data and falsifying vaccination records. So there were many challenges involved in the conventional COVID-19 vaccine supply chain. So our attention turned to blockchain technology, which presented a promising solution to address the challenges of the COVID-19 vaccine supply chain management. I'm sure we all came across blockchain. It is everywhere nowadays. So a definition of blockchain is that it's a digital, decentralized, and distributed ledger in which transactions are logged and added in chronological order. And the goal of this is to create a permanent and tamper-proof transaction record. Why blockchain technology in COVID-19 vaccine supply chain? The main benefit of a blockchain platform is that all members of a supply chain are integrated into one secure network, which improves the performance of the supply chain, as we can see from the figure there. So blockchain will offer decentralization, and this decentralization will help in ensuring transparency, traceability, immutability, security, as much as blockchain can offer, and we'll speak about security in a minute. Automation could also be offered through self-executing smart contracts. Of course, we have an auditable record and can offer disintermediation, which is removing third parties from the supply chain and interactions between the several parties involved. So blockchain offer many benefits for the COVID-19 supply chain. So our interest in our systematic literature review is that we've asked three main questions. How can blockchain technology be used in the management of the COVID-19 vaccine supply chains? Whether there are any challenges to the use of blockchain in COVID-19 vaccine supply chain, and what are the future research priorities for blockchain technology in vaccine supply chains for future pandemics. Our methodology, we answered our research question by conducting a systematic literature review of published literature. And in our review, we synthesized the findings of 35 papers published in journals and conference proceedings on the use of blockchain technology in COVID-19 supply chains. So returning to my first question, how can blockchain technology be used in the management of the COVID-19 vaccine supply chains? And looking at the literature, we found that public blockchains, which are permissionless with no central authority, was the most frequently proposed blockchain platform for COVID-19 supply chain frameworks in the literature. So about 21 papers were focused on or proposing a public blockchain. However, when we've looked at real-world implementation frameworks, we found that they have mainly depended on private permission blockchain networks. And generally, there is a paucity of research on hybrid frameworks integrating both public and private frameworks. Again, when looking at the literature, we found that blockchain implementation was proposed across a wide range of COVID-19 supply chain workflows. So we've seen blockchain proposed in vaccine manufacturing, vaccine distribution, storage, registration, and also in reporting and side effects and vaccination certificate immunity passport. So across all steps of the supply chain, blockchain is proposed to add value. Our third finding is that we found only 38% of the papers reporting real-world experimental evaluations. So among those experimental evaluations were VacuChain by Verma and colleagues, and ImmuniChain by Adarsh and others. But only 38% were real-world experimental evaluations. And of course, this is a limitation because practical approaches would be valuable in identifying potential practical problems for deploying a blockchain platform for the COVID-19 vaccine supply chain. This is just, I thought I'll share with you one practical example. This is a real-world example, VacuChain by Verma and colleagues. And in this example, they integrated blockchain with unmanned aerial vehicles and 5G-based communication networks to support the timely distribution of vaccines. And once the vaccines were supplied to the nodal centers, the blockchain then ensured time-stamped documentation of vaccinated individuals with transparency. And among the benefits reported by Verma and colleagues is that communication latency of 16 seconds compared to 36 seconds in the conventional approaches, and packet loss was significantly reduced to 2.5% compared to 16% in conventional approaches. Generally, if we want to map the benefits of blockchain technology in COVID-19 supply chain, it falls into several areas. So vaccine manufacturing and distribution, blockchain provides immutability, transparency, and traceability, and facilitate the smooth exchange of vaccine transaction data. It also helps in storage of the vaccine in terms of maintaining optimal temperature and preventing vaccine tampering. When we look at vaccine administration, hospitals and clinics manage their stock, mitigating supply and demand constraints, and patients get, or vaccinated individuals get guarantees concerning vaccine authenticity and proper storage conditions. Public authorities could also benefit from the implementation of blockchain platforms in that blockchain can offer an immutable record. So immunity passports are immutable and transparent. Then we move to our second question is, what are the challenges of blockchain use in COVID-19 vaccine supply chain? Of course, despite the benefits of using blockchain technology, it does face some challenges. And in our paper, we categorize the critical challenges of blockchain adoption in 4 categories. The most cited challenge was privacy concerns. So there's a high risk of disclosure of sensitive information. Security, still, there are security issues in blockchain platforms. So still, they are subject to cyber attacks. Blockchain also have issues in terms of its physical constraints, such as cross-chain interactions and scalability issues. In terms of performance issues, blockchain networks consume a considerable amount of energy, and of course, they have high transactional throughput, which leads to communication overheads. Finally, we asked, well, actually, what are the knowledge gaps and future research priorities for blockchain technology? And we recommended 4 future research directions. First, we recommended integrating advanced technologies such as AI and virtual reality, augmented reality with blockchain technology to improve demand forecasting, efficiency, and interaction between stakeholders. We also recommended developing consensus algorithms to improve cross-chain interaction, interoperability, and scalability. Our third recommendation was to develop solutions to security and privacy issues, which is a major concern on blockchain platforms. And some of the proposed solutions is on-chain data encryption, privacy-preserving encryption methods, and quantum-based key distribution. And an area which I'm personally now currently involved in is to explore innovation adoption and resistance issues among key stakeholders to encourage wider adoption of blockchain among supply chain actors. Thank you so much for your attention. It was a pleasure joining you today. Thank you.
Thank you so much. You have explained everything thoroughly. I have one question, can you please name some popular platforms for developing the blockchain applications?
So do you mean the real world examples that has been already developed I'll show you, I'll just share my screen again, which shows an interesting list of real world examples, yes, of blockchain in supply chain. Just share it again. Just that, yes. So those were very interesting real-world applications of blockchain, as you can see there, Doctor. So VacuChain, which is this one, which was implemented, I believe it was experimental in India. And they've tried to use blockchain and integrate it with unmanned aerial vehicles. They use 5G-based communication, and it helped them actually reduce packet loss to 2.5% compared to 16%, which shows that blockchain as a very useful platform for supply chain of vaccines, yes, and many others. So if I had the time, I would have presented the others, but at least we have 6 real-world experiments about how blockchain can be used in supply chains. Yes, immunochain, block cold chain, lobby chain, Vesify. That shows the yes, blockchain could work in vaccine supply chain, perhaps for future pandemics. Yes.
Okay, and why, according to you, data privacy or data security is the important aspect in COVID-19 vaccine supply chain management?
So
Why?
it's innate.
Yeah.
Yes, doctor. Yes. Yes, Ken. So security appears to be the highest cited when we've looked at the issues, especially in blockchain. Security of blockchain, or particularly privacy of or disclosure of sensitive information, appear to be the most frequently cited issue with blockchain. So when we looked at word count, privacy concerns and security issues were the top concerns in terms of actually blockchain is not working as supposed to be right now, and we need to focus our effort in terms of improving, yes, the privacy and security of the chain.
Okay. Okay, thank you so much for your presentation.
Thank you so much. Pleasure joining. Thank you.
Anisha ma'am, we can take the next paper now.
Sure, ma'am. So further, moving on to our next presenter, and I would like to invite Paul Schulz to present his paper on the title, Logistics Dashboard for Transport of Fragile Goods. So dear presenter, you may please start your presentation now.
So I hope anybody can hear me. I share my
Yes,
screen.
we can hear you.
That's nice. So then we use this and okay, here we go. Thank you for introduction. Today I'd like to present my talk about the logistic dashboard for transport of fragile goods. My name is Paul Schulze. I come from the Hochschule für Technik und Wirtschaft Berlin in Germany. I would like to give you a short introduction. In our research project, we are working with Bohr semen. As you can see in the picture, these Bohr semen are transported in such tubes, and they are called insemination doses, which goes to the sow for the breeding. So these Bohr semen have a high requirement in production and transport. And we are focusing on the transport because during the transport, these semen doses can be damaged. For example, because of high temperature or too low temperature and vibration and light. So the problem we was focusing on was that the users, that these are the people from the artificial insemination center, they want to analyze the transport stress and the whole transport process, but they don't have a system for this. So our goal was to identify the requirements of the users for such a dashboard to analyze the complete transport process of these insemination doses. And the second goal was to develop visual concepts as well as user guidance and appropriate system architecture. I would like to give a short introduction in the transport of insemination doses. These are typically transported in those tubes, as you see below, and these are a high fragile good. We have a maximum temperature, a low temperature, and if we are exceeding these temperatures, the good is irreparably damaged. And even the vibration, which is accumulative, leads to a high damage to the product. So they are transported in cooled or heated boxes, depending on the weather, and typically transported in small cars or in small trucks up to 12 hours and up to 1,000 kilometers on the road. And on the picture below, you see a typical last mile of the road in Germany. So it is, you can call it a road, but it's not really a good one. So what was our material and method? We made a qualified interview with 6 selected artificial insemination centers in Germany, Brazil, and the USA. From the results, we make a requirement analysis, develop the system architecture, and final implementation, the dashboard, and make a prototype. So now I would like to come to the first results. The results of the results of the talk to the AI center. So they told us that the transport process is totally different from each AI center. So one of them uses small cars, one of them uses trucks, another one is transporting them all over Germany to one single point and from there on to the source stations. So, and they have no automatic system or controlling system for the whole transportation process. Most of the documentation is done by hand and the controlling is done by telephone. So even the monitoring system there is still not existing. The best existing monitoring system is they use a min-max logger, which they just put into the box. So, and the software they are using really does not fulfill any support for logistics. As I mentioned, they are using telephone and even fax in Germany. So they told us they really need a trace and analysis of the complete transport process, and they really want it. On the right, you see the digitalization of this whole process, and the order and the transport, as well as the retrospective, is not really digitalized at the moment. But such digitalization will lead to preserve the quality of these Bohr Siemens. Now, short a background where the dashboard is built in. We've built a monitoring system to monitor the transport. The existing IoT boxes with measurement devices inside, and the measurement is sent to the back end where the logistic dashboard will analyze the measurement. So now I will come to the use cases or the requirements of the user. They told us that they need to identify problem cases during the shipment. And the problem cases are, as I mentioned, the increased vibrations or too high or too low temperature. And they want to check claim where the fragile good was damaged. And with our product, it's not like a glass or something other fragile. The damage is accumulating over time if you're if you have high vibrations, for example. And they want to coordinate deliveries. If some car is broken, we need to handle this, and they want to send the parcel as soon as possible to the customer because it is highly time sensitive. If the parcel arrives one day too late, it will lead to a claim as well. Yeah, and the other use cases are quite normal for dashboards of logistics. So now some further requirements. They want to have a proper visualization of all of the relevant parameters. I mean, easy to read values of the parameter that are necessary. The reason is the people who are working with the dashboards have not a high knowledge of statistics, so we need to give them a easy to read display. Yeah, and the other further requirements are also quite typical for dashboards. So now I would like to come to the visual concepts we developed. First, you see the temperature with a line chart. That's quite typical. But to reduce this to only one chart, we developed a box plot light. So this is different from a normal box plot. In the center, you see the dot, which is the average, not the median. And the whiskers, they are showing the high temperature and the low temperature, which are recorded during the whole shipment. This is really necessary to get these high and low values, because if you exceed one of these values, even for a short time, our damage is totally damaged. and cannot use anymore because it's a life. These diseases are really, they're alive. So now comes to the vibrations. There you can see we use a bar chart. That's also quite typical chart, but additionally we wanted to print out the high value, and we used some short bars on top so the user can see the average and the high impact as well. And with such information, we can analyze where the damage actually happens. The next chart is quite typical for vibration. It's just a relevant frequency. And the last one is the box plot light again, where we only have the maximum viscous, because if the vehicle is standing still, we always get the displacement from 0. I mean, no vibration, so it doesn't make no sense to print it there.
Sorry for the interruption. As we have the time constraint, so you need to conclude first.
Conclude, okay. Okay. With the dashboard we have developed, we make ensure that the management of the Artificial Insemination Center has the possibility to documentate all of the necessary measurement value and make an analysis where the damage happened. So they can improve their whole transport process to prevent this damage. Yeah. And the next work we will focus on is to build up optimized delivery routes, and we want to optimize them for a low vibration, so that the damage that we can prevent the damage. Yeah, and even to implement further dashboard functionalities. Yeah, this was it.
Okay, Mr. Paul, you have explained everything thoroughly, so I have no queries from my end. If anyone has any query, he or she can ask. Ms. Anisha, we can take the next paper now.
Yeah, okay, sure, ma'am. Yeah, so we are moving forward to our next presenter. And here I would like to invite Kaomi Imai to present his paper on the title, Research on a Multi-Agent System that Mimics Ant Foraging Behavior. So, dear presenter, you may please present your paper now.
Thank you for your introduction. I'm Kome Imai from Tokai University in Japan. My presentation title is Research on a Multi-Agent Systems that Mimics Ant Foraging Behavior. First of all, I'd like to talk about background and motivation. Research on artificial life is increasing as a form of research on living organisms. The emergence of organized behavior by artificial life is attracting attention. Our research objective is focusing on the organized behavior of ants based on pheromones, especially foraging behavior, and establishing an algorithm that mimics it, aiming for high efficiency of cooperative behavior in multi-agent systems. In this report, we conduct a simulation study on multiple ants to clarify the conditions for realizing pheromone-based foraging behavior of ants. This slide shows artificial life. Artificial life is a research field that broadens our understanding of life by reproducing life phenomena using artificial systems, such as computer simulations. Other examples, swarming behavior of birds and fish, pheromone communication in ants. This slide shows pheromone of ants. Pheromone is an information chemical produced in the body of an animal that causes physical and behavioral control effects on other individuals of the same species. Features of ant pheromone used as means of information exchange. Volatile compounds. The meaning of the information depended on the concentration and the combination of compounds. There are many types of pheromones. In this research, we used feeding pheromone and nesting pheromone. This study shows foraging behavior of ants. Foraging behavior of ants means behavior of ants finding food and bringing it back to the nest. Nesting pheromone means pheromone to return to the nest. Feeding pheromone means pheromone to return to food. This slide shows pheromone features. Feature 1 is diffusion over time. Feature 2 is pheromone become more concentrated in overlapping areas. This slide shows pheromone trail. The deception of the behavior described above creates a pheromone trail between the nest and the food. This is called a pheromone trail. Because pheromones are volatile, they are not dispersed when the food is lost or when the trail is different, and they dissipate over time. This means that only the pheromone trails currently in use remain. This slide shows simulation environment. In this research, Unity was used as a simulation environment. This figure is that physical properties can be easily added without programming. This slide shows pheromone model. In this research, the pheromone is a cone-shaped object. This is the state of the pheromone at the moment it is released. The height of the conical object is the concentration of the pheromone, and it diffuses with time. And at the same time, its height in the vertical detection decreases, and it contracts to represent the volatilization of the pheromone. This slide shows pheromone sensor. The pheromone sensor consists of 10 small sensors. This slide shows sensor mechanisms. As shown in this figure, the sensor outputs 0 before contact on the left side and outputs number of pheromones in the areas where pheromones are in contact as shown in the figure on the right. With this sensor configuration, it's possible to detect the height of the food pheromone object, which indicates the concentration of the food pheromone. This slide shows ant model. 2 pheromone sensors, one on each side of the ant model, allow detection of concentration gradients in the left, right, and front, back directions. This slide shows proposed control algorithm. When an ant conducts a pheromone, it rolls 1 degree per sample towards the larger RS and LS, as shown in Formula 5. If the total value of the left and right pheromones are the same, the rotation angle is 0 degrees and the ant moves straight ahead. Since Unity uses a left-handed coordinate system, the XZ direction is the horizontal direction. This slide shows movement during pheromone detection. When LS and RS output 0, the ant searches for pheromone. When RS output 0 and LS output non-zero, the ant turns to the right. When LS output non-zero, RS output 0, the ant turns to the left. When LS and RS output non-zero, ant goes straight. This slide shows simulation objective. Confirmation of the formation of pheromone trail by multiple ants using the proposed model and the resulting emergence of foraging behavior. Confirmation of the effect of increasing or decreasing pheromone volatilization rate on pheromone trails. Confirmation of the effect of the sites on pheromone trails. This slide shows simulation conditions. Simulation 1, 2, and 3 had the same conditions except for the pheromone volatilization time. The number of ants is 5. The ant size is 3 times 3 times 3. And the field size is 0.21 times 0.21. The pheromone volatilization time is 90 seconds for simulation 1, 120 seconds for simulation 2, and 150 seconds for simulation 3. This slide shows simulation screen. The red cylindrical object on the bottom left is the nest. The apple-like object on the top right is the food, and 5 ants are placed around the nest. And the simulation time is 5 minutes. The simulation is then started in this manner. Results: simulation 1. Pheromone trail wasn't formed. Simulation 2. Pheromone trail was formed. Simulation 3. Pheromone trail wasn't formed. This slide shows a graph showing the time response each coordinate in simulation 2. Ant 4 detects Ant 3's pheromone at 110 seconds, showing in blue line. And Ant 5 begin to return to the nest at 210 seconds after the red line, following Ant 3's pheromone, indicating that the pheromone trail has formed. When the pheromone volatilization time was 90 seconds, consider that the pheromone volatilized before the pheromone trail was formed, and thus the pheromone trail wasn't formed. When the pheromone volatilization time was 150 seconds, pheromone remained in the field and the ants overreacted, and thus the pheromone trail wasn't formed. Therefore, we consider it necessary to establish an appropriate volatilization time to form a pheromone trail from nest to food. This is a table of pheromone volatility time and field size. Check mark means pheromone trail was formed. Hyphen mark means pheromone trail wasn't formed. Diagram line means that if the pheromone dissipates during the time it takes ants to travel from their nest to a food source and back. From this table, it can be seen that the size of the field and the pheromone volatilization time are related to the pheromone trail was formed. Our research objective is focusing on organized behavior of ants based on pheromones, especially for gene behavior and establishing an algorithm that mimics it. Aiming for high efficiency of cooperative behavior in merge agent systems as a result, we conduct a simulation study on 5 ants and confirm that the proposed model can form pheromone trails and generated for gene behavior in multiple ants. And pheromone trail formation is related to the increase or decrease in pheromone volatilization time, the size of the field. This slide shows outlook for the future on research. Construction of cooperative control algorithms for application to merge agent systems and its simulation study. Thank you for your attention.
Thank you for your presentation. How many research papers you have already studied regarding this domain?
Thank you for question.
I want to ask you regarding your literature review. How many research papers you have already gone through for the multi-agent system and with regard with your this domain? I would suggest you for your next presentation, you should include your literature review also. The papers which you have, research papers you have already gone through.
In this research, 5 ants, but futures.
Okay, Yeah, can you please explain me that what are the different computational complexity in multi-agent systems?
For multi-agent systems, for example, rescue assessed roles for researchers and nanomachines in blood and searching the internet using trace, so display over time.
Okay, thank you so much for your presentation. Anisha ma'am,
Yes, ma'am.
are we done with all the presentations or are we left with one more presentation?
So for now, we have completed all the presentations, but I just wanted to ask if we have Ruxi Jiang here in the meeting, because only that presenter is left. Okay, so we don't have them here. No problem. So for now, we have completed all the presentations for this session. And now I would just give the closing remarks. So I sincerely thank all the presenters and for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. And I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this version and the previous 7 versions of the conference. And I hope we will be happy to have you in the 9th version in 2024. So all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. So the publication will be live within 6 months, and kindly cooperate with the team of ICICT 2023. And I would also like to thank our session chair, Professor Monica Rathod, for chairing the session. And we thank you for your valuable presence, ma'am.
Thank you, ma'am.
And here is a small token of appreciation on behalf of the team of ICICT, Global Knowledge Research Foundation and partners.
Thank you so much, ma'am. So thank you all presenters for their illuminating presentations and discussions. The presenters around the globe exchange their diverse research ideas, and they have covered the different topics like blockchain technologies, DevOps, multi-agent systems, and the deep neural network. So thank you all for sharing your research and knowledge with us. Thank you so much.
Thank you so much, ma'am. And now, as we have come to an end of the session, I will request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Thank you.
Thank you. Goodbye.
Thank you very much.